Hi, I'm Len Epp from Leanpub, and in this episode of the Leanpub podcast, I'll be interviewing Qiusheng Wu. Based in Knoxville, Tennessee, Qiusheng is an associate professor at the University of Tennessee and an Amazon scholar. His research focuses on geospatial data science with an emphasis on using open source Python tools and cloud computing to study environmental change. He is the creator of several widely used Python packages, including GMap, leafmap, geoai, and is dedicated to advancing geospatial analysis and visualization. Dr. Wu's work is a cornerstone of the open source geospatial community, and he brings his deep expertise to this book, guiding you through the process of learning and mastering geospatial programming with Python. You can follow him on Twitter at GISWQS, and check out his very popular YouTube channel, Open Geospatial Solutions, at the same address at GISWQS. You can also find his collection of open source software packages for the geospatial community on GitHub at github.com/OpenGEOS. Qiusheng is the author of the book Introduction to GIS Programming, a practical Python guide to open source geospatial tools. In the book, Qiusheng equips you with the skills to tackle real-world geospatial programming challenges. Whether you aim to build sophisticated spatial data applications, automate geospatial workflows, or simply enhance your analytical capabilities, this book will give you the confidence to succeed in the field of GIS programming with Python. So that's the end of me reading Qiusheng's own descriptions of himself and his book. In the rest of this interview, we're going to talk about his background and career, his professional interests, his book, and the importance of open source and things like that. And at the end, we'll talk about his experience now as a writer of a self-published book and as a popular YouTuber. So thank you very much, Qiusheng, for being on the Leanpub podcast.
Yeah, thank you for the invitation, Lane, and thank you for the introduction. Yeah, I'm really looking forward to the conversation.
Yeah, me too. Me too. I always like to start these interviews by asking people for what I call their origin story. I'm not the only person who does that. And I was wondering if you could talk a little bit about where you're from and how you found your way into a career as a professor doing, geology and sustainability and everything like that.
Yeah, of course. Yeah, I grew up in a remote countryside in southern China. It's called Guangdong Province, so next to the close to the South China Sea. And my parents were farmers, but they're still farmers right now. So after so many years, and so it's kind of very remote area, and education level was pretty low. So I was um, helping my parents like growing rice and all the vegetables like, but I really hate doing the farm work. So to be honest, so and my dad told me the only way out is to go to school. Otherwise, you will be a farmer just like me. So and I worked kind of pretty hard, and I was lucky to get into the best high school in our town. So and then go into the top university in southern China, Sun University. But I kind of selected GIS. GIS stands for Geographic Information Systems. So at the time, I think it was 2003, when I got admitted, my parents had no idea about what it is. Also, they actually wanted me to become a doctor, a medical doctor, not a real doctor like now, because they know like medical, like doctor is a profession that's being highly respected in China. But so in China, when we apply to get into college, there's a so-called college entrance exam. So unlike here in the US, people can select whatever major that they like. In China, we don't have that kind of privilege. So everyone need to take one exam, so the college entrance exam, and they have different subjects. For example, literature, mathematics, chemistry, physics, something like that. And so it kind of life changing. So you need to really perform well in order to go to a good college. And so I think I did pretty decent, but my score was not high enough to major in to get into medical school. And I think I kind of selected some kind of atmospheric sciences or something like that. So after the exam, or actually before the exam, so when you apply, you actually have to apply to submit the application. And there's a checkbox asking you, do you want to be assigned to study the major? So basically, you can get into a good school, but if your score is not high enough, they will assign you to study a major that's not very popular. That not many ones selected. And I'm not sure if it's kind of a unique education system in China, because there's so many people, and it's hard to come up with a system that's fair to everyone. And so for us, it's still the only way out of poverty. And so I checked the box saying that I want to get into this top university, But if my score is not high enough to the major that I chose, you assign me to other major. And that's where I was assigned to study GIS, so Geographic Information Systems. And it was pretty new at the time. So and end up I like it. My parents saw I was studying like geology, going to find gold mines or oil, something like that. It's it's not. It's just basically using computer to study geography. And it's kind of intersection between computer science and geography. And then I think in 2005, Google released the Google Earth, and was very transformative. That I learned like, oh, it's pretty cool that you can see the entire globe using just computer. And then yeah, so that's how I like ran into GS like by accident. I was actually not I didn't choose GS, but and then so I finished college and then go into graduate school in China. And then met my kind of a advisor here in the US. He went back to China for a conference. So we met, he liked me and then recruited me to Texas A&M University. And then I studied there for one semester. Then he moved to University of Cincinnati. So I followed him and then got my master and PhD over there. So I spent 6 years in University of Cincinnati, Ohio. And then yeah, and then after that I started working as an assistant professor at the State University of New York for 4 years before I moved to Tennessee here. Yeah, so it's kind of by accident, and also YouTube is also by accident because
Yeah,
of
well,
pandemic.
yeah,
Yeah.
you talk about the YouTube a little bit later, but yeah, thanks for sharing that really great story. So I have to ask a selfish question. So my parents were both grew up on farms,
Uh-huh.
and my grandparents were all farmers, of
Oh,
course.
really? Okay, that's cool.
And my grandfather on my mom's side
Mm.
liked farming and was very good at it, and my
I see.
grandfather on my dad's side hated farming and was very bad at it.
Uh-huh.
Um, I just and but the way out
Mhm.
for my parents was education and going to university and things like that. But I wanted to ask you about probably there's a big difference between farming in Saskatchewan province in Canada
Mhm.
and the province you were from in China. What were the seasons like? So, for example, here I'm
Mhm.
actually in Saskatchewan right now,
Mhm.
in the middle of Canada. It's very stark. It's kind of semi-desert in summer, and it gets quite hot, but it gets very very cold in winter. So there's 6 months of the year when there's no farming. There's caring
Uh-huh.
for animals and machinery,
Uh-huh.
but there's just no farming.
Yeah, for us, I think we farming four seasons because it's in southern China. It's very humid. It's the weather is kind of similar to Florida here in the US. So it's very much similar. So it's like a very tropical region, and we have hurricanes every summer. And it was like I kind of experienced it the first hand because over there the farming is very different from here in the US. That you have machinery, large like tractors. No, in China at the time it was all labor. So basically, I stay in the farm whole day just to like grow rice, grow other vegetable, and then there's no irrigation or anything. So you have to have like the water buckets and then take the water bucket to water all the vegetable and all the stuff. It was really tough. It's really, really labor intensive stuff. Of course, after I left and then last 10 years probably they have a lot of like advancements. So now they have some machine to do that. But yeah, it was really like underdeveloped and very, very challenging. And that's why I really hate that I want to escape from the poverty from the area. And but yeah, it's not. And also, what I remember is whenever there's hurricane during the summer, so all the farms, for example, the rice, everything will be destroyed. So basically, it will be inundated, and then they will be all like destroyed, and then you will not be able to harvest anything because once it's inundated, yeah, it's not dry, and then going to grow like so basically everything will be gone, and also the house, not really a house, is like very shaky, like home, like, and the rooftop can be flow away during the hurricane. And I remember whenever it rains, uh, the entire floor be wet because it's like water leaking like from the roof everywhere. So it's unlike here, it's like house is concrete, and laws is no, you know, it's all like don't know how to explain to that. It's very uh very very poor, and so that's why I try my best to like go to school. But I was lucky because I was the I think 4 or 5 kids that go into college from our entire village. So we have like thousands of students, probably I think only 10 roughly at the time, only 10 students were able to go into top universities at the time. So like 20 years ago, it's rough. Yeah.
Actually, it's funny. Education and systems in different countries is actually one of the sub themes of the podcast because we get authors from all over the world and all
Uh-huh.
backgrounds. And I'm very curious. I mean, I don't know a lot about Chinese history, but I do know that the idea of kind of centralized examinations
Yes.
goes back thousands of years,
Uh-huh.
basically, and that there were the sort of traditions, very old traditions about like how people had a path to these examinations
Exactly.
that would completely transform your life if you could get through it. What and I just know some stories, but like everyone would gather and they would say the names of the people who passed,
Exactly. Yeah.
and you would
Remember.
just be sitting there like in the there was some I think there might have been even a term for being the last person named
Uh-huh.
and what that experience was like. You knew there was one name left. So I guess I'm just curious about your experience. Was it obvious to everyone that like there was a way out, and if you studied hard enough, you could potentially do it, or did your parents sort of have to be resourceful and know and find out and put you in a special school or something like
No, it's like because in the reason is really the education is pretty below average compared to the national. And there are certainly some people, if they're rich, they can have some relationship, they can donate something to the school, and then they can get in. Just like in the US here, if your parents are rich enough, you might have a way to get into Harvard, MIT, or whatever. But in China, it's similar, like if you're rich. But I mean, in that area, is reason is very poor. So my parents told me, if you don't want to be a farmer, you study hard, you go to school, but there's no way I can buy you into university, buy you into college. We don't have the money, we don't have the resources. And he sometimes joke like, I can sell blood to get some money for you to go to school. Because even when I was admitted to the Suyenshan University, a top one in southern China, I didn't have the money to pay the tuition because the tuition like 4 years or every year, I think at the time was like 5,000-6,000 yuan, less than $1,000. My parents didn't have that money, so my tuition was donated by my relative to actually to get into the college to pay the tuition for the first year, and then after that I applied for kind of like what's that in here student loan just like here in the U.S. and then I pay back after a couple years. And very somewhat similar when came to the U.S. My parents didn't have money, so I think I have like 1,500 case when I came to the US, all donated by my friends that just to come here to see because my parents like there's no way they can support me to come to the US. But it turned out very well. Like if you work hard, there's still a way out. But I mean, in China, there's just way too many people. It doesn't mean if you work hard, you will get a good life. Sometimes you need to be lucky, and if your parents don't have the resources, then sometimes you just like it's the destiny. It no matter how hard you work, you will still cannot change your life. So I still I think I'm the one of the very luckiest person because I was able to change my life through education. So even though the system here, people outside of China probably think it's really unfair why people you can assign people to study a major that they don't choose. But I mean, it's just too many people want to go to university and like they are tens of millions of people taking the exam every year. So it's only one time only. If you didn't perform well, then your life is pretty much it's hard to change. And unless your parents is rich enough to get you somewhere, yeah.
Yeah, no, that's you're reminding me there's a particularly, sometimes people can react, "Oh, you're told what to study," can
Mhm.
s can seem kind of draconian, but, our societies and our socioeconomic kind of situations have other ways of telling us what we can and can't do anyway, and sometimes it's just, people's reaction to the kind of explicit version of it is really just a kind of way of repressing the other ways that we're
Mhm.
forced into things in our lives anyway, but, yeah, you reminded me, I think there's a European country where you can choose what you wanna major in, but if you wanna become a professor, they tell you where to go.
Uh-huh.
Uh, and so these versions of these systems and sort of managing it exist in all kinds of places. Another kind of sub theme of the podcast, of course, is people changing their lives not just through education but also through moving.
Mhm.
So I moved around a fair amount in my life.
Mhm.
And I'm just curious, what was it like for you moving to the United States? Did you already speak English when you came?
No, 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 no. I mean, we went to college. We study English when we. I think we also in high school we also study English, and then we need to take the exam when we have the college entrance exam. You will need to study, but if you can tell, I still have very strong accent. And it's hard to change. So, but in that reason. The other one is about computers. So I think in the nowadays people, like when they are kids, they can play iPad, they can play computers. In my time, I didn't have access to computer until I finished high school. Until I got admitted into university. So I spent, I think, a couple of weeks to like go to a Chinese school to learn how to do typing, like and um, so even though I mean I was like scored really high in my high school, when I got admitted to the university into college, I was still at the bottom because I knew nothing about the computers. But all my classmates, many of them are free from relatively developed area. Their parents relatively rich. They already know how to computer for a long time. They already know the internet. I knew nothing about it. So you have to study very, very hard to actually catch up, because when you get into a good university, you are at the bottom, then you need to move up like through your hard work. So, and English is the same thing. So in China, you like people are very good at text, maybe reading and other stuff. But I mean, in terms of speaking, I mean, even though in an environment that it's speaking a lot, then I mean, once you come to the US, you still need a lot of work to actually improve yourself. So I was I mean, before I became a professor, I mean, I was very shy. I don't really talk a lot. I mean, but now I don't care. Like your English is not very good. You have accent. Who cares? Like as long people understand you, they're fine. I never try to really have perfect accent or speaking English. But as long as you convey the message, people know you. It's okay. So that's just my take.
Yeah, no, that's a really amazing story. Uh, one one thing I wanted to talk to you, but then moving on to the next part of the interview where we talk about your career and everything like that. So and your book. Let's maybe move into that area. So, can you talk a little bit about what geographic information systems are and a little bit about the history of that?
Mhm.
You already talked about one big moment, which is around
Mhm.
2005 when Google Earth
Mhm.
took out and all the technology and
Mhm.
data availability that would have been necessary for that to happen. But what's a little bit of the history of your field?
Yeah, so actually when I started, I mean, started in college in 2003. So at the time, GIS was still relatively new in China, but it's already relatively developed in the US and also in Canada. So GIS stands for Geographic Information Systems. Although right now you might also hear like Geographic Information Science. So basically we are trying to change from like being a tool to being a discipline or being a science. So basically it's kind of a discipline dealing with spatial data, location data, using computer technology. So basically, think about any data that we're collecting daily, right? It can be data from the satellite, it can be data from your cell phone, so anything tied to a location. So pretty much, I mean, anything around the on Earth surface is tied to a location. So it's dealing with space and time. So, for example, how urbanization changes, how the river changes, or Wi-Fi or anything like anything you can capture using satellite data or drone or lidar. There are so many platforms, and so the discipline, I mean, has a very long history since the 1970s. So we have software development, and then now we have so much better because with all the tech companies, for example, Google Map, Apple Maps, Google Earth, those are actually all geospatial technologies. I mean, in general, although developed by big tech companies, but it's basically how you use computer to analyze geospatial data, how to visualize geospatial data, how to gain some insight from geospatial data, and to make decisions based on the data that we have.
Yeah, it's really interesting. I mean, the cover of your book has a great example of the use of this kind of science, which is it's a map of the United States with like a kind of
Uh-huh.
the height of buildings,
Yeah, the medium home price. Yeah.
home price. Yeah. So it's very interesting because I mean, when we hear when an ordinary person like me hears
Mm,
geographic information system, yeah, we might think about
mm,
rivers and lakes and mountains.
mm,
It's sort of an environmental kind of things,
mm,
but yeah, as you say, anything with a
mm.
location.
Yeah, exactly. For example, right now, if you go out, if you take a Uber to a taxi, or even like for example, Amazon delivery, that everything related to location. So basically, it's a time and also location. So it's moving really fast. So we have lots of data you need to analyze using this kind of geospatial technology.
Yeah, and another example, I mean, to bring up farming would be, for example, I know that I think around here, there are farmers who kind of know they now have enough data and sophisticated enough ways of analyzing it that they can plant differently on different
Mhm.
parts of their farm.
Yeah.
So that would be another example of
Yeah, definitely. So basically, farming, agriculture, forestry, they all use this kind of GIS. So you can use drone imagery to capture the data, and then you know whether, for example, your farm it has disease, or is it like healthy, is not healthy, and when you can harvest. Like, so you can analyze the data. You can also, based on historical data, to predict what is going on, and those data are very helpful right now for those farmers, especially if you have a large farm. You don't really have the resources to like go every location, so you can have those sensors, either satellite or aerial platforms, to capture the data and then analyze the data. So you can basically have some kind of automation rather than have to do very labor intensive work.
Yeah, it's very fascinating too, to field, because I mean, one thing, when the mistake I think sort of ordinary people like me might make when they look at a map is they're like, oh, that's it, we've captured what the land is like.
Mhm.
But of course, things are changing all the time. They're changing minute to minute. And I looked up your doctoral dissertation kind of description, and I just wanted to ask you just a very specific
Mhm.
question about that, if you remember, because
Yeah, yeah.
people don't. But I believe you came up with the concept of a pore contour.
Contour tree, yeah.
Okay, yeah, and could you
Yeah.
talk a little bit about what that is? Because it just sounds very interesting.
Yeah, contour tree basically is just like similar to what we in GIS we have the digital elevation, so you can join a contour. Contour means basically kind of like you're drawing a line, basically the same elevation around in the digital elevation. So it's be used to basically represent the relationship between different objects that you detect from geospatial data. So the idea is that you can create a representation of the object on the Earth's surface. Kind of like it's just a hierarchy from your parents to your children, and then from your children to your grandchildren, something like that. So the idea is like, think about here. You might, let's say you have it's the concept we use to delineate so-called the surface depressions or wetlands on the landscape. So think about, you might have a big, for example, a depression on the landscape, but inside it's not just a bullshit depression. You might have smaller ones, just like you on the road. There might be a lot of like sinkholes or something like that. But when you have water flooding the surface, it's not like all at once it's flooded. It's like a gradual process. So, for example, the water flowing from here and then from to this upstream sinkhole, and then going to flow to another downstream. So you can construct a relationship. You know exactly when these two wetlands might be connected together, because there are a lot of species living in those wetlands. So it's kind of a delineate so-called the surface network. So you know, for example, oh, if the fish is in this water pond, you need how much water to actually flood it, and then so they can connect two small water ponds, and then they can jump from here to here. So basically, also related to species migration, and it's also on the landscape. You might have like two mountains, and then you might have a big mountain on top, right? So you can basically have a hierarchy. So-called a contour tree is to basically a high elevation, and then you might have some nested structures inside, and eventually you can actually figure out the relationship. If the water increase, these two be joined together. Kind of like, if there's going to be a flooding, and then you get two houses like in here, you will know that when this one is flooded, at some point you want to connect the water going to flow to this one. So you know it's coming, how long it's going to take, something like that, like this kind of application.
Yeah, no, that's really fascinating. I mean, and it gets to the kind of like the breadth of the usefulness.
Yeah, I can give you like, for example, this is
Yeah.
like, right? You have two cups, and assume that you might have water floating, like all rainfall drip from the sky, and you will know exactly when this one is going to fill, and then when it's going to be the water going to flow to this one, or you might have the other one on the other downstream. So basically, you have a whole network that you can figure out the relationship between those two. Is this your upstream? Is this your downstream? And then how many downstreams? How much water you need to be flooded yourself first before it flood to the downstream.
Right, which is that's so fascinating. Of course, like,
Mm.
it speaks to the breadth of the sort of application, right? Because then it's kind of urban planners
Yes.
now need to know, they can use this kind of these
Mm.
ideas to sort of understand how they should design a city, or if a city's already been designed maybe thousands of years ago, what's
Yeah.
going to happen if it rains X amount and things like that.
Yeah. People have used text to delineate, for example, starting urban growth and also tree. For example, you can use to delineate trees. You can think about here, have a tree, and then we have so-called LiDAR, light detection and ranging.
Yeah.
You can have the so-called elevation. So you need here, or this is two small tree and there's a bigger tree. So you can actually see the relationship of those trees.
And I'm curious. I know from having interviewed some data science professors and people like that over the years. There was like a big kind of explosion of data
Mhm.
Right, and in well, machine learning also, around like 2010 or 2012, maybe even as late as 2015. Did that explosion of data have happen in like the GIS world as well?
Yeah, it's the same thing. So actually, our data is much larger than the computer science applications because usually, for us, we have lot more satellite being launched every year. So we get a lot more satellites, and also the resolution becoming higher and higher, right? So for example, 30, 40 years ago, the satellite, for example, the resolution is roughly maybe 30-meter resolution. So basically, every pixel is 30 meter by 30 meter. But now we have 10 meter, we have 5 meters. So you can think about the volume is actually increasing like exponentially because right in the past, like 30 meter by 30 meter is just like 900 square meters, just one pixel. But now we have like 1 meter. So think about like 30 times by 30, so 900 times. So in the past, if it is 1 megabyte, now it's 900 megabyte, 900 times. The increase is dramatic. And we have more satellites where the resolution become higher and also become more frequent.
That's what I was gonna ask you.
Yeah, so in the past, for example, you can get the revisit frequency maybe every 2 weeks. Now you get every day. So and even for something like you have like every hour or two, you depends on the location. So you can actually get a much higher revisit frequency, especially for weather and forecasting. You can wait for 2 weeks. It's just too late. So we have some of those satellites. It might be coarse resolution, but basically all the spatial data from satellite, or also the so-called remote sensing satellite, has so-called spatial and temporal resolution. So spatial resolution means what's the area it represents. Right? It can be 30 meter by 30 meter, it can be 10 meter, it can be 1 meter. And the temporal frequency basically means how often do you get one imagery. So it depends on different satellite. You might get every week or two or every day. So there are different type of satellites. But in general, um, the size is pretty big compared to traditional computer science applications because most of the computer science, for example, machine learning, computer vision, is dealing with just RGB photos. For example, RGB photo. In remote sensing, it's very different. We just not only have RGB, we have so-called spectral. So you can have multispectral, basically have from RGB and near infrared and short wave. They will have a high spectrum, and we also have so-called hyperspectral data. Usually have 200 spectral bands compared to three like 200 spectral bands. So the volume is much larger. So you are dealing with gigabyte, terabyte, petabyte. So lots of those satellite data, for example, NASA, Google has, is usually at like 100 petabyte scale. So it's really huge. And we definitely need, we blow a lot of algorithm from computer science, computer vision, but we need to do some customization because many of those algorithms you cannot directly use to apply on remote sensing data because it's not RGB. It's multispectral. It's hyperspectral. We also have light detection and ranging. So basically, the data is much more complex compared to the traditional computer vision applications.
Yeah, it's fascinating, in addition to being more complex, and there being so much of it, it's also open and available, which is actually one of the interesting things that I think, sort of, people who might these days take having, like, internet access, that's, like, the same thing as electricity or something like that.
Mhm.
But it's not just the amount of data, the openness and availability of it, and of the tools as well is something that is actually, like, a relatively recent
Mhm.
phenomenon. People of my vintage, when we think about launching a satellite to take
Mhm.
pictures of the Earth and get data, that would be like we'd think of militaries doing that
Mhm.
and things like that. But now,
But now we have civil applications. So
yeah,
for example, NASA, USGS, they release those data, and they start making those for free. I think starting from 2003 or something like that. I forgot the exact time, but it's almost 2 decades now. So and it's keep continuing. So we have satellite mission. For example, Landsat is the longest running satellite mission since 1972. And so it's like almost 5 decades of data available. So you can always go back in time to see how the Earth is changing.
Um, and so all of this is actually a big buildup to talking about your book. And one thing that I hope has become clear to anyone watching or listening is that this, geographic information systems or science is
Mhm.
so widely applicable that it's actually useful to all kinds of different people from all kinds of different backgrounds. And so writing an introduction to it or making the many videos that you've made as an introduction has this great challenge, which we've seen many authors on Leanpub go through in their
Mhm.
own way of where do you start when you're trying to explain
Mhm.
something like this. And it's, for example, like it's not just sort of scientists or kind of
Mhm.
people in the military or farmers, journalists, for example, these tools are incredibly powerful. So if you've ever seen a story about like what happened, what a town was like before and after a
Mhm.
forest fire, like we get up here
Yeah.
in Canada, and you can slide left or right on an image, you actually show people who can come from, there's people who are like, their work is as a journalist, and now they've been tasked with, kind of coming up with one of these images. What would they do? Maybe they might know, they probably know how to use a computer and type, but the command line interface might be like
Yeah.
a completely unknown thing to them. So I'm sort of curious for anyone who's interested. Okay, so like I would love to be able to use this
Mhm.
for my vineyard or my
Mhm.
my garden or what have you, um, uh, or for an article for my paper. What's the first step that you do in training? If someone showed up to you and they were a complete blank slate, you didn't know anything about them except they had an interest in learning how to use these tools to get those kinds of results, what's the first thing you teach?
Yeah, first thing I would just send them to the website. So I have some web applications that's very easy to use. So it's, for example, creating satellite time lapse. So if you want to see how the Earth is changing, we have, like as I mentioned, Landsat satellite for 50 years. So I have those web applications that people can go to, and all they need to do is just zoom into the location that they're interested in, and then just simply draw a rectangle, and then click the button, and then you will join the animation. 20, 30 seconds. You can do it for any location on the globe. Very much similar to Google Earth. I guess many of the listeners know Google Earth, right? So Google Earth also have the kind of a time lapse. Right, you can go back to many years ago, and it's kind of very much similar. But um, Google mostly focus on a lot of high resolution satellite data, but we also have a lot of satellite data in the public domain. So you have like much higher temporal frequency. So basically, you can customize. So for example, they say you're a farmer. You want to see how the vegetation has been changing. For example, the last couple of decades in this particular farm, you can just easily go there, draw a rectangle, and you can customize. Okay, I want the data for every year, or I want the data for every quarter, or every month, or every day. It depends on your specification. Then you will be able to go online to actually collect all the data and then create, removing all the cloud. So one of the challenges in using remote sensing, optical remote sensing, is cloud. So cloud is going to basically block the reflectance. You will not get anything. But with a lot of data, you can actually remove the cloud, so you can get a pretty decent, good quality picture of the year. Of course, if every pixel is cloud, then you have nothing to extract from. It's very challenging, but it's kind of similar to nowadays in the cell phone, right? You can take a photo and then maybe take a bunch of photos, and not every photo is good, but you can combine together using AI. You will generate a good quality photos. So in remote sensing, especially using cloud computing, we have similar tools. For example, Google Sensing allows you to create a mosaic. So basically, they say you have 100 images for this location, and every image, some portion is good, some portions are not good, and the other image might be different. So basically, what it's doing is basically pick up every pixel. So get the base pixel in this base pixel in for this location, and get the base pixel for this location. So
Mm.
you end up with a nice picture. Kind of like if you go to Google Earth, if you zoom in, you see there's no cloud, everything is perfect. It's all fake. So those images have been processed because at any time during the day, the globe is entire globe is covered 60-70% by cloud. So you're gonna basically have in reality you're gonna have a lot of cloudy images, but it's not. It's all really beautiful because it has been processed. So every pixel is coming from a different time. So this pixel here might be from like in June, the other one might be from February. So they're trying to create a so-called cloud-free mosaic. And so it's same thing in geospatial. You can go to my web application and draw a rectangle, and then you say, okay, I want to do it for every year. So you can showcase, for example, urban growth in Las Vegas, or landslide, whatever. As long as the data can capture that, you can do that pretty much easily. Yeah.
That's fascinating. Thank you very much for, sorry for the pun, clearing that up. I always wondered why the pictures were always so clear, and there were no clouds. And I always thought, oh, they just pick a day when it's not cloudy.
It's
But
not like pick the base pixel.
right,
It's not,
yeah,
for example, your imagery, maybe a photo, it looks like this. It only picks the one pixel. So this pixel might from this imagery, the other pixel from the other imagery. When you put every pixels together, it looks perfect.
okay. No, that's fascinating. And so that makes a lot of sense. That the first step for somebody would be, how to sign in, and if you know how
You
to
don't need to sign it, just go to the web and then draw the
go to the
rectangle
web.
and then download. Yeah.
Yes, exactly. So, but then probably they're going to get hooked or they're going to have more advanced needs. And so eventually they're going to have to learn some programming.
Uh-huh.
And that means learning the Python programming language.
Yes.
Could you talk a little bit about what, for someone who the brand new, what's Python and why would they need to use, in what circumstance would they need to use it and do a little bit of programming?
Yeah, so I mean, if you want to download things from the website like manually, I mean, just creating one or two, that's perfectly fine. But if you're doing things repetitively, then programming is probably going to help you a lot. So think about, let's say you're a farmer, you're trying to see maybe monitor the farmlands, and let's say you are very rich, you have like 50 farmlands across the U.S. There's no way you can go to individual one and then try to create the time lapse like manually. It's going to take you a while. But using programming is just basically just a simple looping, and then it's a specified location, and then maybe have all the latitude, longitude in the file, and then you just program, it just loops through the file, and then create it automatically. So I'm a big fan of automation. So if I will automate everything if I can, right? So I highly recommend that if you're doing anything, and if you're simply just clicking the mouse and then doing it like repeatedly every day, there must be a better way. So automation using Python or using basic script, there's so many ways, and you can just right nowadays use all the large language models. Just ask question, how do I make this one efficient? There's a way to do that. So Python is like very popular because with all the AI, pretty much like everyone is using Python. So if you know some basics, it will make your life so much easier. So I write code pretty much every day, and from writing a book, everything is automated. Kind of using a combination of Python script and basic script, so you can compile the book very easily without having to manually do things on your own.
And is it also, Python comes in handy too when you're using different kind of data from different sources that
Yeah.
make different formats and things like that.
Mm.
Help you. Things might seem like they're incompatible with each other, but you can build something
Yeah, definitely.
based.
So in the book, basically, I cover like variety. Geospatial. We have so many formats: vector data format, raster data format, and vector. You also have come with different like just like video, right? You have MKV, you have AVI, you have MP4. There are so many variations, but using Python, you can have packages that can read pretty much any geospatial data, and then convert them, for example, to geodata frame, just like pandas data frame, and they can use to combine different workflows together to generate results.
And I know that, open access to things is very important to you. Open source kind of programs and things like that is very important to you. But also being open about your own work is very important to you. You have this very popular YouTube channel with many, many, many thousands of followers and things like that. And you've got entire courses on there and things like that. How did you get into, and so we're moving into the final part of the interview where we talk about your work as a content creator and author and things like that. So how did you get into YouTube? Did you just like take to it naturally? Just started live streaming and
Actually, I really do live streaming, mostly just uploading the video.
oh, okay.
So I kind of started during the pandemic. So in 2020, like we all in pandemic, and then all the courses move online. So I have to actually record at the time of staying home, and then recording the videos for my students. And in 2010, I was trying to teach my students how to use Google Search Engine, basically cloud computing using Python. So at the time, the Google Search Engine basically don't really have good support for Python. And I kind of learned the open source mapping libraries, and then make it easy for people to visualize geospatial data in the cloud. The analogy is just like I make it easier for people to watch movie using Netflix, for example, using Amazon Prime, because we have a lot of geospatial data, and there are a lot of data in the cloud, but it's not very easy to actually to visualize the data. So I built a GMap package just at the time just to teach my student how to use Python. And so pandemic hit, and then I have to move online. So I basically doing two things: developing the packages today, and then teach my student tomorrow. So I have to record some videos, and then I was saying maybe I can just put on YouTube, because the student I need to upload the videos anyway. So to the learning management at the university. So I just put it on YouTube, and then I started creating a short video teaching people how to use the package, and a lot of people found it useful. So I kind of keep creating, developing, and then slowly I kind of when I was teaching other, for example, spatial data management courses, GS programming, I record it when I'm teaching in person. So I just record the lectures in class. I don't just create a video for YouTube. When I'm teaching in class in person, I just start recording my screen. And once the class is over, I upload the video to YouTube. So my students, they can watch it afterwards, people outside the university, they can also watch. And so I kind of, this is what I did. So there's no really actual work that I need to do because I'm teaching in class anyway. I just record a video so student can always go back because all my courses are kind of very practical. So I teach them step by step. There's no slides, so I don't have all my lectures. I don't have any slides. It's just showing step by step how to do programming and how to analyze data, visualize data, and so. I mean, when I go starting, I was really kind of shy. I don't want people to actually watch the video. So whenever I mean, this is the time when I really started to know. Oh, my voice looks like, sounds like I didn't know. And you were trying to very skeptical because you need to edit the video to cut out all the things that doesn't sound right. And so the last couple months, I spent a lot of time trying to edit the video, but I was not good at that because you need to learn all the video editing. And at the end, I gave up. I was like, this is not my priority. I just don't want to have all the fancy production. And then, so a video is only half an hour. You might spend an hour or two to edit a video. It's too much time. At the end, I gave up. So nowadays, I never edit my video. I record in class, and when it's done, I upload, and I don't watch it again. So yeah.
Yeah, thanks very much for sharing that. Actually, that's something a lot. I think everybody who gets into kind of video, kind of whether it's sort of like, training people how to showing people how to do things, whether it's even entertaining them. A lot of people, we our first instinct is to kind of edit all the rough
Yeah.
edges and things like that. And one thing you learn is that I mean, when you say like recording half an hour of video in an hour and a half or something like that, that's a really good ratio. Often it can be like if you see a plural site video or something like that, it might be 1 hour, might take 10 or 20 hours
Uh-huh.
for the person to produce. So that's the first thing you realize is how hard it is. And then the next thing you realize is that most people don't really care. And they in fact find the kind of rough edges kind of endearing and humanizing. And as you say, because they can go back and forth,
Mhm.
um, if something was a little bit done too quickly, they'll just go back and they'll do it again. I do this all the time when I'm watching lectures online, for example, even very prepared ones. I go somewhere in my own head, and it's like,
Mhm.
oh, I haven't even been watching the video for the last 5 minutes while I've been thinking about something, and I can go back
Yeah.
and do it. And when you realize the control that we have
Mhm.
over the things that we're watching nowadays, and the fact that we can watch them over and over again means that actually that having like something be super clean isn't really necessary anymore. And that's something that content creators we all have to go through our own path to get
Yeah,
there.
definitely.
But that's very good. And another thing, and just looking at your book, of course, as well.
Mhm.
And I'd like to ask you specifically about how you made that. But getting feedback is actually really important too. So with YouTube videos, for example, people can leave comments for better or worse. And they can say, "Oh, you went over that too quickly," or "Oh, you skipped a step," or "You started talking about the command line, and I don't know what that is." And then over time, you as the person making the videos or the books and things like that can learn. Um, so moving on to your book where you do ask for feedback in there and you explain to people where they can reach you and stuff like that. So specifically, it's a very good looking book. Uh,
Mhm.
what tool did you use to write it?
So I use everything is open source. I use Mist Markdown, mystmd.org. You can go there, you can try it out. So basically it's a markdown by some special flavors dedicated for publishing. Mist Markdown for basically writing the content is basically just Markdown. And then I also use Jupyter text to convert between Markdown and Jupyter Notebook because with a lot of source code, you need to taste the source code. So you can actually synchronize between Markdown and Jupyter Notebook. So when I'm writing, I prefer to use Markdown. And when I need to taste the source code, I convert it to Jupyter Notebook automatically. So you can convert the entire book into Jupyter Notebook, and then I can run that so I can test it, make sure the source code, everything is reproducible, everything works fine. And so that's for writing. But in terms of creating the PDF, compiling the PDF, I use um, types, TYPST. So it's kind of a new typesetting system, similar to LaTeX, but it's so much easier to use.
Okay.
And also, there's not a whole lot of dependencies. The project is still relatively new, but I really like it because it's very easy to use, and also it's very very fast because it's developed based on Rust language, and it's fantastic. So basically, everything is coming from the delineated from the MIST. So it's just the open source packages. So you can write and then just one command line, for example, MIST build, and then you can build the entire book, and then you can generate the PDF automatically. So it's pretty nice.
That's great. I was curious about the PDF. And so you've got your book up on Amazon in print as well as on Leanpub.
Yeah,
Uh,
it's the same thing. So basically, it's the same as the one in Leanpub. The only difference is for the print version, I need to adjust the margin from the inside and the outside. So I mean, for example, the margin, it's 1 inch on each side for the PDF, but it's like 7.75, and then one maybe on the printed. So the pages number might look different. But I also need to had to learn how to put the book cover, because Amazon KDP has a special format, so you need to figure out how many pages, and you need to design the book cover. But yeah, everything is free, so there's no cost. So the entire book is just my label. I don't spend anything like to purchase anything. I design the book cover, and then actually it's very simple, just a simple screenshot and also some text like.
yeah.
It would be great to have hired a designer, but I say that's not just my strong point. I just like mostly just convey the knowledge, not about how fancy it is.
Yeah, well, I mean, I think it's a very good cover, and but yeah, as you point out, like, sometimes the simple covers are the best as
Mm.
well. And, yeah, and so also you've been publishing translations of your book as well. So, I believe you've got, Japanese, Chinese, and, Spanish as well as English. How have you been producing those translations?
Yeah, so basically, it's also learning, good learning experiences. So especially for the last couple weeks, we have a Gemini CLI and also Call and also Cursor. Like basically, those are popular IDE used for doing like programming. So and also maybe some because I'm Chinese. I mean, I have a lot of demand from people in China want this book, but many of them don't have know English very well. They want the Chinese version. I was thinking, okay, maybe let me translate, see how it works. And so I guess basically use a call to translate the book, but because the content is very long, and I have to try even for one chapter, right? So basically, you cannot dump the entire chapter into the AI because the context window is just too big. So I have to subdivide into small sections and basically uh, use AI to convert the markdown from one language, like basically from English, for example, to Japanese. And then, but sometimes there's some weird issues. So this, usually for each language, I think it takes half a day for me to actually to figure it out and to do the translation, and then eventually need to combine as a PDF. And sometimes there's some weird encoding issue. The characters don't show up correctly, so I
Right.
have to go fix that. And the other tricky issue is the number of figures and also the footnotes, right? So you need to make sure they the same, because if you have 150 figures in English version, you need to have 150. Sometimes okay, there will be 148. So then you need to have okay,
I know.
where is it missing? Why is it not translating? What is happening?
Yeah.
Basically, I use a combination of base script and also Python to automatically generate everything. So generate, for example, the table content, and then generate the markdown, and then automatically compile the PDF. So I have a kind of system set up that once I get the translated version for each chapter in the markdown version, and then I will build it as a PDF, and then I need to extract the table content and then put on the website. So yeah, in general, it takes half a day. I mean, a couple hours, because AI is great, but also you cannot abuse it. So you will exceed you will deal with the rate limit after a couple hours,
Right.
and then so once it's done, you need to wait for 5 hours. So I mean, if you can even use it all the time, I can get it done maybe in an hour or two. But because my membership is like the pro membership, so only allows you to use certain much. So I maybe translate one third and then wait for 5 hours, another one third, 5 hours, and then so
Yeah.
it takes time. Yeah.
Yeah, no, thanks very much for sharing all that great detail as well for anyone who's looking to do the same thing. That's
Mhm.
like kind of golden to kind of learn that kind of stuff.
Mhm.
The last question I always like to ask on the podcast, if the guest has been using Leanpub and is a Leanpub author, is if there was one, I know you used our upload writing mode, which is
Mhm.
relatively straightforward, but
Uh-huh.
if there was one magical feature we could build for you that you were thinking, oh, I only wish Leanpub had this, or if there was one thing that had you shaking your fist when you were using
Mhm.
the platform and you were like, damn you, Leanpub, fix this, this is broken.
Mm.
Can you think of anything you would ask us to do that?
I think it's pretty easy to use. The only thing I wish they have is for the I think for the about page. Right now, I think it support HTML, but I pretty much use Markdown exclusively. So it'd be great to support kind of Markdown, like I can just copy and paste, so I don't have to manually reformatting the stuff. But
Right.
uh, I think right now what I did is like I have Markdown, and then I render the Markdown, and then just copy and paste that one to HTML, and then I need to just make some minor adjustment. But it'd be great that if it's supposed markdown, then I don't have to manually convert it.
Yeah, that's a great suggestion. So for anyone listening, if you write a book sort of using Leanpub, then we automatically generate a table of contents for the landing page for your book, so everybody can see, oh, chapter 1, chapter 2, chapter 3. But if you upload your book in PDF format, for example, then you have to write out your own table of contents to show. And currently, you have to do that in HTML. And sort of, fortunately, many Leanpub authors kind of don't find that too daunting, but some do naturally enough, because it's frustrating if you don't know what it is. And so actually having a simpler way of doing it, like in Markdown, is a very good suggestion. Well, Qiusheng, thank you very much for taking time out of your day to talk to me and to talk to all of us about this. And thank you very much for using Leanpub as the platform to publish your great book, Introduction to GIS Programming, a practical Python guide to open source geospatial tools. It's already proven very popular with many readers, and so have the translations. So congratulations on the new book.
Yeah, thank you very much for the invitation, Len, and also the great conversation. I really enjoy it, and also thank you for maintaining Leanpub. I mean, it's a game changer for me. Like for somebody that don't want to go through the traditional publisher. So for me, I really enjoy it because I can upload it and then it become available to anyone on the globe. And if something goes wrong, I can change the PDF. I can upload it again. And so for me, I really want to share things with people around the globe, and I don't want to wait. If I have something to share, I want to share it right away.
Thanks.
Thank you very much. Yeah.